page 9 because you can read it.
Yeah.
Answer.
Yeah, Jaden, you probably have about the neatest handwriting, and Marianne, probably about the worst. I called her out. All right, we are. You guys remember what we did yesterday?
Yes, I do.
Found the volumes of prisms and cylinders. How do we find the volume of a prism? Well, we found the area of the base, whatever it was, whatever shape the base was, and then we did that times the height of the prism. So if it was a triangle, we did the triangle area times whatever. If it was a cylinder, we did the circle area, pi r squared times whatever, right? So that's for prisms and cones, prisms and cylinders. They have two equal bases, they just go straight up. Sometimes they're leaning over, but today we are doing pyramids and cones instead of prisms and cylinders. So we're doing these two guys. So what do these two have in common?
They both come to a point.
Right, they both come up to a point. They have one base on the bottom, whatever that shape is on the bottom, but they both come up to a point. So would a pyramid have more or less equal volume to a prism with the same base and same height?
Same.
Let me say that again. Would a prism with the same base...
Oh, okay. It'd have more.
Gotta do that backwards.
Yeah.
Anyway, would a prism with the same base and the same height have, or would the pyramid have more or less volume?
Less.
Why?
Because it
only has one base.
and the sides are larger because with the triangle you have to divide by 2, whereas those the rectangles.
Doesn't have anything to do with the size. What did you say?
Well,
Huh?
it can.
No, it doesn't have to do with the triangular shape. It has to do, well, pyramids, they're sucking in, right? These are going straight up. But these are like caving in. So there's a lot of volume, there's a lot of space that's not being taken up that this takes up. This is a lot bigger. And actually it comes out to, this is only going to be a third as big as this. So today, instead of just doing area of the base times the height of the prism, we're going to do area of the base times the height of the prism divided by 3. Okay, that works for cones and pyramids. Anything that comes up to a point, we're doing the same thing as yesterday, except for we're dividing by 3. If you look at it in the book, it says 1/3 because that's like dividing by 3, right? Multiplying by a third. But it's easier to plug in the calculator, divide by 3. So that's what we'll be doing. All right, ready?
So this one should be real easy.
Actually, I didn't write this down on the board, but I don't want to. Number 1, we're not going to do. So number 3,
I know the answer. Come on.
what's the answer?
Capilliaries.
How'd you know that?
I'm smart.
Yeah.
He looked it up.
Wait, no, I don't know that.
Do you look it up in the back or do you look it up on the previous page?
Yeah, no, how do you know that? Capilliaries.
Congratulations. Number 3. Okay, so we're doing the area of the base. Number 3 has a pentagonal base. How do I find the area of a regular pentagon? Or regular polygon in general? No.
It's the
1/2 apothem perimeter. You guys remember that? For any regular polygon, like a pentagon, octagon, all those things, you can use 1/2 apothem times perimeter, or you can call it apothem times perimeter divided by 2. That's the same thing. Okay, so on number 3, what is the apothem? 7. Okay, on number 3, what is the perimeter? Or how would we find the perimeter?
10.
10.2 times 5. Okay, that's the apothem, that's the perimeter. Divide by 2. Okay, that's the area of the base. And what did we do yesterday after we found the area of the base? Times the height of the pyramid in this case, which is what? What's the height of the pyramid on number 3? 24. That line that goes straight up and down. Yesterday we would have been done right here, but what do we need to do today? What's the new thing? Divide by 3. Pyramids and cones are only a third of prisms and cylinders, so you have to divide by 3 again. Every time today, divide by 3. So we need to plug all that stuff in. That is correct. Ding, ding, ding. And this one is in millimeters. 1428 millimeters cubed. That's it. Okay, number 5 is a pyramid, but the base is kind of weird. By the way, on number 4 is a cone. So how would we find the area of the base on number 4? Pi r squared for the circle base. Number 5, what is the shape of that base though? Trapezoid. How do we find the area of a trapezoid?
Base 1 equals base 2 divided by 2.
Right. Average the bases, 3 and 4.2. The bases of the base, little bases of the big base. Average the bases times the height of the base. Okay, that would just give me the area of the trapezoid. Once I find the area of the trapezoidal base, what do I do with that? Times the height of the pyramid, which in this case looks like 4. And then what do I do after I do that? Divide by 3. So if you don't use parentheses on this one, you would get it wrong, because the order of operations would screw it up. Parentheses are important on this. Actually, if you plug in 3 plus 4.2 divided by 2, that would be wrong also. So here's what I would suggest. Just do 3 plus 4.2 in your head. 7.2, right? And then just plug in 7.2 divided by 2 times 2.5. That would work. Just have to add before you do everything else. 7.2 divided by 2 times 2.5 times 4 divided by 3. What'd you guys get?
12.
12. I think this one is meters. Okay, number 7. Same thing, they didn't draw a picture for us, and I don't think I'm gonna try. Number 7, find the volume of a 35-inch tall pyramid, so another pyramid, whose base is a rhombus with diagonals 24 and 29. Who remembers how to find the area of a rhombus? Diagonal times diagonal divided by 2. So the area of the base, 25 times 29 divided by 2. Okay. Oh, it's 24. Times 29 divided by 2. Once we get the area of the base, what do we do with that? times the height of the pyramid, which they said was 35.
Yeah, 35.
And then, what do I do after that? Divide by 3. Every time today. That was not too bad. There's a bunch of stuff. What'd you get?
I'm not speaking.
I don't think so.
It's a big number.
4060. Does anybody agree with that?
Yeah.
4,060 inches cubed. Number 9, a Canadian student designed the regular octagonal teepees as unique packaging for herbal teas. Good to know. What volume of tea can each package hold if the pyramid is 6 inches tall and the base has an apothem of 1.2 inches and a perimeter of 8 inches? So the problem says it's a regular octagonal base. So how do we find the area of a regular polygon? We did this. 1/2 apothem perimeter. Or apothem perimeter divided by 2. I'll do that. So what's the apothem?
What? Oh.
The apothem was 1.2. What's the perimeter? 8. They just told us the perimeter. They didn't make us find it. Divide by 2. Okay, that's the area of the base. And then what do I do with the area of the base? Times the height of the pyramid, which they told us was 6. And what do I do after I find that? Multiply the height? Divide by 3. Jasmine, are you paying attention?
I got
9.6. 2 people got it, that's gotta be right, I'm guessing. This was inches cubed. Okay. Number 11. How tall is this pyramidal packaging for pasta? Each side of the square measures 6 inches, and the volume is 108. So, you guys see what's different on this one?
They're asking for volume.
Right. We already know what the volume is. They're asking us to work backwards and find the height. You guys know how we're going to set this up?
Like the formula.
We're going to use the formula like we're going to find the volume, and we're just going to set it equal to the volume that they gave us. So it says it's a square pyramid with the sides of the base being 6 inches. So what would the area of the base be if it's a square with 6 inches on each side? 6 times 6. Okay, not the perimeter, the area. 6 times 6. So the base is 36. What do I need to do after I find the area of the base? Times the height of the pyramid. Oh, we don't know what that is. So that's where I'm going to put my variable. And then divide by 3. And that should give us the volume, which they told us was 108. So there's a couple ways we could go here. How could I solve this for h? Do a little bit of algebra here.
36.
We could simplify 30. You could, there's 2 things you do. You could multiply by 3 and divide by 36. Or you could simplify 36 divided by 3 is 12h. And then what would we do? Divide by 12, right? Does anybody remember their 12s? No, not 12.
No,
It's not.
9.
Let's go.
Did you remember? Nice. I think it's inches.
Yeah.
Okay. It's not cubic inches because it's just height. What?
Can I sum up on 12?
12 is pretty much the same thing, I think.
Whenever I read it, I get a little confused.
No. Well, we're not doing the evens right now.
Okay, never mind.
Obvious.
All right, 13. Wrong page. Shoot.
Find a ball on each.
Find a a hexahedron. You guys remember what a hexahedron was? Six-sided
Yeah, I know.
polyhedron. What would a what a six-sided polyhedron look like if all the sides were the same? We've seen a lot of them.
A cube.
Cube, yeah. Remember boxes have 6 sides? So if it's a regular polyhedron, it's a perfect cube. Just like my picture is perfect. All right, anyway, how would we find the volume? It says the edges are, edge is 3. How would I find the volume for this?
3 cubed.
3 times 3 times 3, right? Cubes have all the same size. So the base is 3 times 3 times 3 for the height. What's 3 cubed? 27. So this one is just 27 cubic yards. Okay, 15. How do we find the volume of a regular octahedron? Well, what you do is you flip back to page 430, flip back a page, and there's a little yellow table in there, and they give us a formula to find a bunch of these things. You guys see octahedron in the table?
Sure.
The yellow table right there. So it says V volume equals square root of 2 over 3 E cubed. What do you think E stands for?
Edge.
One of the edges. So all we have to do is plug in the edge they give us, which was square root of 2. Let's see if we can do this without a calculator. Now, on the evens, if you use a calculator, that's fine, but do you guys remember what square root of 2 times square root of 2 was?
Square root of 4, which is 2.
2. Square root of 2 times square root of 2 is 2. Anytime you square a square root, they cancel out. So we have square root of 2 times square root of 2 times square root of 2 times square root of 2.
Then you cube it.
No. I already cubed it. Square root of 2 times square root of 2 times square root of 2, cubed it, times square root of 2. Square root of 2 times square root of 2 is 2, times square root of 2 times square root of 2 is another 2. So I got 2 times 2 is 4, over 3. And the units are meters, so meters cubed. Notice I put the square root of 2's on the top because it's like square root of 2 over 1. Okay, on the evens, I do not care if you just plug this in your calculator, it'll give you the answer. If it gives you this or a decimal, it doesn't matter. The book has both answers, so we're good either way. So you can just plug that in your calculator, it's fine. Number 17. Same thing, this time is a tetrahedron. Do you guys remember what a tetrahedron was? 4 sides, remember what it looked like? This thing. 1, 2, 3, 4 sides. It doesn't really matter though, because we just need to use the formula they give us, which is square root of 2 over 12 E cubed. So we're just going to plug the E in, which was a 2, I think, wasn't it? So we're just going to plug in 2. So, do you guys remember what 2 cubed was? 2 times 2 is 4 times 2 is 8. So it's 8 squared root of 2 over 12. And then, can I do anything to that? 8 and 12 are both divisible by 4. Again, you could have just plugged this in the calculator, that's fine. Right there, just plug the numbers in the formula.
How'd you get 12?
It was part of the formula right here.
It says it in the specifications, like on page 43.
Well, are you doing the evens not following along?
No, I was confused because.
I got the formula from the table on page 430. Alright, anyway, that's the last one. And if you get a decimal on these, that's fine. Decimals work. Hey, I said number 20 is a bonus if you want to try.
Oh, you have to do
That one.
you have to do Pythagorean theorem on the like to figure out
No. How would we find the? You don't need the Pythagorean theorem. How would we find the area of the base on number 2?
Oh,
If the hypotenuse is 2, how long must each side of that square be?
12.
wait.
Or sorry, I said 2. If the hypotenuse is 6, that each side must be 12.
Yeah.
So how do I find the area of that square?
It's 12.
12 times 12.
Yeah,